So in this last lesson, we're going to model from data, and data can be given to us in a number of different ways. It can be given in a table, it can be given in a graph, it can be given as coordinates, it can be given as a description in a paragraph. So let's look at these three tables, A, B, and C, and we want to figure out what type of function they are. So we see that A is linear because we have a constant rate of change of +2, okay? And so we would say there is a common difference of 2, and so that for A, it would be f of x equals 2x plus 3. If we work our way back, we find our y-intercept when x is 0 is 3. B is exponential. How do we know that? We have a common ratio of 1.5. And so for B, we would write f of x equals 6 times 1.5 to the x minus 1 power. Or if we took it back to when it's 0, 4 times 1.5 to the x power. Okay? Either one is interchangeable. Depends upon whether you start with the y-intercept or you start with the first value. And C is quadratic. And the reason is our second difference is 6. Okay? And when we would work through this, we'd find that f of x equals 3x squared. Okay? We would use one of our strategies of plugging in points to figure out our values of A, B, and C. All right. So we take a look. A student is conducting an experiment. The number of cells are growing, are decaying here. All right. So what we see is our common ratio is 0.55. How do we get that? We just divide one number by the number prior to it. Okay. So that we see that our function is C of m equals 5 million times 0.55 to the m power. That's because I'm starting with my y-intercept. If I started with at time 1, then I would have to the m minus 1 power. Okay? So that at C of 16, I would have 350.57 cells. Okay? All right, going on. We have a township that has the population increased by 20% for the first 10 years and then 5% after that. So if the population is 150,000 people in 2010, what is it in 2000? So that means I got to work my way backwards. If it was 150,000 people and I had a growth rate of 5%, so I want to know what it was 10 years before that. All right. Well, if I do this math, I'm going to divide 150,000 by 1.05 to the 10th power, and I'm going to get about 92,086 people. Okay? So in this case, it says, how would you round your answer? The normal situation is, since it is population, it's preferable to round down. Okay. Now, what was the population in 1990? So now I'm going to start with my 2000 population. And since I was growing at a higher factor, I've got to use 1.2. And when I do that same math, I get 14,872. And then what would the population be if the trend continued in 2009? Well, the simple thing to do is to take the 2010 population of 150,000 and divide it by 1.05 so that you'll get 142,857 people. That's just the easiest way to do this math-wise. All right, and then finally I have this graph. It's obviously a parabola. Okay. So it says how many days would it return to $12 a share? And so based on symmetry, it would be, or it would take 12 days. I mean, I'm sorry. Yeah, 12 days. All right. Because it says if it's at time 0, so what you see here is at time 0 it was 12. At time 6 it was 3. All right, so my 2 points are 0, 12, 6, 3, and 6, 3 is my vertex. So I need to find the point that is on the opposite side. So if I'm 6 units away this way, then I'm 6 units away on the other side, which is how I get to 12. Okay, so now I want to write my quadratic equation for this. So I'm going to say V of t, since I have the vertex, I can use the vertex, is equal to a times x minus 6 squared plus 3. So now the question is, what's the value of a? Because we don't know if it's 1, 2, or some other number. So now I take one of my coordinates. The easiest one is to take 12, 0. So I put 0 in for x, 12 in for v of t. When I do all of that math, I find that a is 1/4. And again, all of this is easily checked with your calculator. So v of t equals 1/4 x minus 6 squared plus 3. And then to find what the value is after 15 days, I put in 15, and v of 15 is $23.25.